Hello and welcome to second lecture in the 21st chapter in our comprehensive course on AI, ML and DS. Now, in last lecture we were talking about multicollinearity and here we stopped why multicollinearity needs to be handled. Now we take a practical example and we will use the tips dataset which is provided by default in the SNS library. Now, I will do the things in mostly that order which will become a kind of repetitive order for all the projects or all the examples in future chapters. So first step is always importing the libraries. So we import Seaborn as SNS, matplotlib.pyplot.splt, pandas spd, and statesmodel.states.outlier influence. From that, import variance inflation factor. Now this is often rarely used and therefore many people tend to forget this. However, this variance inflation factor, VIF in short, is a very important thing. So please remember this: state models dot states dot outliers underscore influence import variance inflation factor, right? So that is how you will import 4 libraries and then you will load your dataset. As I said, if you had this dataset in tips.csv file and you can write it like this: df is equal to sns.load underscore dataset tips. So instead of that, if it is tips.csv file present here, then you can write pd.read underscore csv and tips.csv, right? So that is how you would have imported it. But here it is built in dataset with SNS library. SNS you have already imported. So now you can just use sns.load underscore dataset tips. And if you forgot, then our standard method is there, sns dot, and you will put a press tab character and then go down until you get something related with loading L or something. You can directly press L also, so that load dataset, okay, and then you can write the name of the dataset in quotes. So you are loading the dataset and this is my dataset. Apparently it looks that there are some numeric variables like this total bill, tip, and maybe this size also. It might be categorical, we don't know, but we will see how to check it. And this seems to be categorical variable, sex or gender of the customer, female, male, then smoker or non-smoker, day, which week day it is, or week and day, Sunday, Monday, Tuesday, Wednesday, what day of the week it is, and time. Now we can do some more analysis and you must cultivate this habit. As soon as you load a data set, first thing you should do is check its top 5 rows. You can also check bottom 5 rows by df.tail, right? If you want more number of rows to be checked, say top 10 rows, then put that number in the parenthesis. If you don't put any number, then by default it will show top 5 rows. But if you put any number like this, then it will show the number, that many rows which you have specified here in the parenthesis. So here you can write df.head. You can also show df.tail. Then you should create, as such here this is the next step. But in between I am adding a few, cells, and certain things you should always cultivate a habit of doing, because the more time you spend in understanding your data, the better it will be for you. So df.info, that will give 2 informations: how many nulls are there in your data set in each column, are there any NA value or non-values, and second, what is the data type of each column. So it gives this information. It gives this many rows are there, their index is 0 to 243, this many columns are there, and you can see the data type of each column. So float 64, total bill, float 64, tip, while the sex, smoker, day, time, these are categorical variable. So these 4, these are categorical variable, and the size, that is the size of the group which has come for lunch or dinner in the restaurant. So how many people in one group have occupied the table, that is what it is, and it is given as int 64. Okay, so info gives a lot of info. Similarly, next is always df.shape. Now shape will be redundant. If you have done info, then shape would not be required. But if you want, only shape without a parenthesis, then it gives number of rows and number of columns. But you have already done df.info, so that information is already there with you. So then df.describe. Okay, and describe directly gives the statistical summary of your data sets. So that means it will give, if you don't specify anything here, then it will only give statistical summary of numerical variables. So that means this top 2 and this bottom size. Okay, it will not include categorical variable in that, because for categorical variable there is no point in finding mean, median, or standard deviation, etc. So count is the number of rows. What is the mean bill? Then that is this much. What is the mean tip size? This much. And the mean size, that is this. This is the average group, average size of the group. Okay, so average, on an average around 2.56 is the size of the group. That means between 2 and 3 people visit the hotel on an average. Then standard deviation in each variable. Minimum value of total bill is $3 and the tip minimum is $1. Size minimum is 1. Maximum bill is $50. Maximum tip is 10, and maximum group size is 6 people. This is 25 percentile, 50 percentile, and 75 percentile, right? So that is also our well-known thing. Then if you want, you can do one more thing. Here you can write include is equal to all. So if you write all, then it will give the summary of both statistical as well as numerical variable. It looks slightly what you call uglier, but actually it is a good habit to do that, because even in categorical variable also, the summary will give some other information. For example, for the this sex or gender of the customer, that top gender is male and its frequency is 157. That means out of 244 customers data that you have, more than 50%, 157 is the data for male customers. Then mean, median, all they are none, because it is meaningless to talk about mean, median, etc. for this kind of categorical variable. Smoker, then in smoker also, top category is non-smoker, and there are 151 non-smoker. Day, the top category is Saturday. Maximum customers are found on Saturday. 87 are the records for the Saturday. Dinner is the maximum time, preferred time. That means out of 244 rows or 244 records, 176 records are for dinner time data. While all these are none, that is expected, because for non-numerical variable, categorical variable, all these mean, median, standard deviation, maximum, minimum, they don't have any effect, right? While these unique top and frequency, they do not have any effect for this numerical variables. So that is why for those unique top and frequency, you will find none in these two numerical variables and these numerical variable size, right? So that you can see. So always have a habit of doing include is equal to all. Okay. Now the important thing is about this data type. This is my data type, and here these 4 are categorical variables. Now I want to find correlation. Okay, our topic is how to study multi-collinearity. So if I just directly find correlation matrix, then I will have to simply drop this column. In fact, in some earlier chapter, we have dropped this 4 column straight away, and we have taken only 3 columns, that is total bill, tip, and the size. But every time we cannot afford to drop the categorical columns, because categorical columns also contain important information. So before finding correlation between all these columns or features, you need to convert the categorical variable into the numeric variable. Now there are that process of converting categorical variable into numeric variable, that is called encoding. So converting this into numeric variable, that process is called encoding. And there are many different techniques for encoding. 3 main techniques are: one is called one-hot encoding, another is called label encoding, and another is also called target encoding. Target encoding is slightly sophisticated and usually not used, but one-hot encoding and label encoding, they are very, very frequently used. So in this chapter, we take an opportunity to introduce one-hot encoding for categorical columns. So what we do is, first we make a list of all categorical columns. What are those columns? Sex, smoker, day, and time. So we are making a list of those columns. Take columns sex, smoker, day, and time. From which data set? From data frame DF, because this is my DF data frame, right? And then apply pd.getDummies, this function. PD means this feature, getDummies. That feature is provided by which library? Pandas library. We have already imported pandas as PD, so I can use pd.getDummies. So always read the right side first. Initially, forget about this drop first is equal to true, but you can write pd.getDummies, then data frame name DF, and the categorical column names in the form of a comma separated list of columns. Okay, and that result, whatever comes of this, that you stored in a new data frame, you can write df2 also, or df, but better will be df underscore encoded, so that we always come to know, as soon as you see the read the name, you become clear that here some encoding has been done in this data frame. So that means data type now may look numerical, but actually before, some in earlier step, the data was categorical. Okay, and then we will plot this df encode, print this df encoded dot head. As soon as you get any new data frame, first thing which we do is this thing: we get head, info, and describe with include is equal to all. So same thing we will do here also. So we will print head. Now what this pd.getDummies do, if you want to understand perfectly, then first let me make this drop first is equal to false, because then you will understand more clearly. So if I put this drop first is equal to false, and then I write, now you see this and compare it with earlier data frame. Maybe this was my earlier data frame, so I can write df.head once again somewhere just above this, so that you can easily compare. So this was my earlier data frame before encoding, in which a few were numeric variable and few were categorical variable, while this is my same data frame after encoding. I am saying same data frame, but it is not looking same data frame. It is looking that number of columns has suddenly increased, right? Now that is the characteristic of this getDummies function, or that is the characteristic of one-hot encoding. That for every categorical column, that is this sex, for example, it will give two encoded column if the number of categories are two, because here sex column has two categories. The number of categories are female and male, and that is why there are two columns generated, sex female and sex male. Okay, and how the data point would be named, the data point is still same. You can see that total bill is 16.99 and the TP is 1.01. This is total bill is 16.99 and TP is 1.01. But here it was written very clearly under the sex column that sex was female. Now here we are writing sex male is equal to false and sex female is equal to true. Okay, and this false and true are internally stored in Python as 0 and 1. So false means 0 and true means 1. So that means this categorical column, which had two values, female, male, but their values were string variable, instead has been converted into two columns, and they have numeric variables 0, 1. Similarly here second row, if you check, that total bill is 10.34, TP is 1.66 and the sex is male. So here 10.34, TP is 1.66 and the sex male is true now and the sex female is false, right? So that is means what is happening is this binary encoding is given some symbol. Okay, so wherever female sex is there, then in the sex female column true or 1 will come, and in sex male column 0 will come. And similarly wherever male sex is there, in that observation in the sex male column 1 will come and sex female column 0 will come. Of course 1 appears as a true and 0 appears as a false. That is a different thing, but internally they are 1 and 0 only. Similarly smoker. Now in smoker also there are only two categories, either it can be no or yes. So smoker, first 5 observations if you see, they are all smoker no. So here too the smoker column is removed, and instead of them 2 columns are generated. Again smoker yes, smoker no, and first 5 rows they had all smoker no. So that means smoker yes is false for all those rows, right? So you can see false, 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 and smoker no is true for all those rows. Okay, now regarding the day. Now day has many different categories, maybe Sunday, Monday, Tuesday, Wednesday, like that. Okay, or here in this case I think it is Sunday, Saturday, Friday, Thursday. Four days are there. So this data set had only 4 days. Here you can check how many unique categories are there in the day column. Then there are 4. So whenever such column is removed, that is encoded, then that column will be removed, this categorical column, and it will be replaced by 4 numeric columns. So one will be day underscore Sunday, another will be day underscore Saturday, another will be day underscore Friday, and another will be day underscore Thursday. Now if you see here, all 5 have day underscore, day is equal to Sunday. So for all, day Sun equals will be 1 or true, and day Thursday will be 0, day Friday will be 0, day Saturday will be 0. But if I add one more cell and there I write df.tail, maybe that means last 5 rows. Okay, so in that these are all Saturday, and one last record is Thursday. So if you here also write df encoded instead of head, if you write tail, then you will see that for those all first 4 in the tail they were Saturday, right? So that is why df Saturday is equal to true for 1, 2, 3 and 4, and all others were false. It is not Thursday, so 0, not Friday, 0, not Sunday, so 0, and Saturday it is, so 1. Similarly for this row also, and this row also, and this row also. But last row, it is Thursday, so it is Thursday, so 1, true. It is not Friday, so false, 0, not Saturday, 0, and not Sunday, so that is also false. Similarly in the lunch time, there are 2 categories, and the category you can see by this df.describe include is equal to all, and 2 categories, lunch and dinner. So that will be converted into 2 columns. Here there is only 1 column, time, in which there are 2 categories, dinner and lunch. Okay, but that will be converted into 2 columns, time underscore lunch and time underscore dinner. And wherever, in whichever row the time underscore lunch is there, then dinner is there. First top 5 rows they have time equals dinner only. Even bottom 5 also have time equals dinner only. So this is again encoded data frame and tail bottom 5 rows. So time dinner is equal to true because time is dinner for last 5 rows, right? And time lunch, it is not lunch time, that you can see here for the bottom 5 rows. So this is the encoded data frame. Its bottom 5 rows will show that dinner is true and lunch is false. Now that means how one hot encoding works, then for each categorical column, the original column is dropped and it is replaced by as many new columns as is the number of categories in the original categorical column. So sex had two categories, therefore it got converted into sex male and sex female, right? Smoker had two categories, so it got converted into smoker yes, smoker no. And you can see the beauty of pandas that you don't have to specify anything, that right yes, no, or male, female, or anything. It automatically finds the categories from the original data frame and it automatically gives the column header some proper name also when you just write pd.get underscore dummies. That's all. Okay. Then day has four categories, so it will be removed and it will be converted into four numeric columns. Time has two categories, so it will be converted and into two numeric columns, like that. Now I come to this drop first is equal to false. Isn't even this a redundant information? Because say, is it required to take sex male and sex female both columns? Because if suppose the sex female column is not there, right, only sex male column is there. So if sex male is true here, so it is clear that sex female will be false because it is mutually exclusive options. Similarly, if sex male is false, then it is clear that sex female will be true. So in short, whatever information this column gives, that information is already included in this column. So I can drop any one of these columns, right? So that other one already contains the same information. Similarly, smoker yes is equal to false if I keep that column. So it is clear that there is no need that for first row smoker yes is equal to false, so then smoker no is equal to true. That is just a redundant information because he is not a smoker, and this also says that he is not a smoker, right? So first observation 239 observation or record number is not a smoker, but both these are giving the same thing. Smoker yes is equal to false or smoker no is equal to true. Similarly, about day. Now about day it is a little bit complicated, so that we will do later on. But about this time first. There again there are two categories, so there is no need to give both. For example, for this 239 very first row here, that it is dinner time. So time dinner is equal to true. Then automatically it is not lunch time. That is clear. Okay. So that means time lunch is equal to false. There is no need to speak it that. So if you speak like this, that for record 239, it is not lunch time and it is a dinner time. Now you can speak, but you are speaking redundant information. So you can just write for record 239, it is a dinner time. So then it is not lunch time. That is removed, right? Similarly for these also. Now out of four, actually any one day is possible. No. So if you keep only whatever day is true, for example, for observation 239 is for Saturday, then it is clear that that observation is not for Thursday. That information is already covered. Or 239 is not for Friday. That information is already covered. And 239 is not for Sunday. That information is already covered. So that means that if you write that day is equal to Saturday true, that automatically implies that Thursday, Friday, and Sunday are false. So what I am saying is that out of these two, you can keep any one. Out of these two, also you can keep any one. Out of time lunch and time dinner, also keep any one. And out of day, also you keep any one. Now then you will have less number of columns and still it will contain all the information. So that is the meaning of when you write drop first is equal to true. So here you just have a look at this, or maybe let me just paste this output for your record so that you can have that as a record. I am making this markdown cell and I am pasting that image. Now I am writing drop first is equal to true. Okay, and this is that old drop first is equal to false. So you can see what is happening is first, that is sex underscore male, that column is dropped because its information is already covered here. Smoker yes, that column is dropped because smoker no already covers that information. Day Thursday, that is dropped, and other three columns are kept. Okay, and similarly day time lunch, which is the first among the two columns, that is dropped, and time dinner is kept. So this is less number of information and therefore we will keep this. So here this is just a markdown, and here I will write that below is the output that we would get if we select drop underscore first is equal to false in above line of code. So then this is just an extra information, but we will always prefer to have less number of columns and still retain all the information. Now if I do the same things as earlier, as soon as new data frame is created, so by one hot encoding what you have achieved is from the DF, that is this data frame whose last 5 records are these and top 5 records are these, you have got this data frame whose top 5 records or last 5 records are these. You can also write top 5 just for the sake of continuity. So in that case, this is the top 5 records, right? Or the pasted image is for bottom 5. So let me keep the bottom 5 only. So these are the last 5 records. These are last 5 records when drop first is equal to true, and this pasted image is last 5 records when drop first is equal to false. Okay. Now as soon as you get new data frame, you have to do df underscore encoded, and first thing which you will do is the info. So now you can see all are numeric variables. Boolean is also numeric variable because, as I said, internally it is stored as 1 and 0, and the remaining were already numeric, float and int 64. So all are numeric variables, and therefore I can easily find the correlations. That is one thing. Similarly, I can also find df underscore describe, and I can write include equals all and control enter. Sorry, df dot describe, control enter, and you will get this information. Now you can get statistical summary. Still for Boolean variables also, though they are converted into numbers, still there are only two values, 0 and 1, so their mean etc. don't make sense, right? But the advantage of that is that now you can find correlation matrix using df encoded dot core. If I try to find correlation matrix with this df in which 4 categorical columns are not yet converted into numerical, and if I try to find, then you will see it throws error, right? And it will show that could not convert string to float, no. That is this, for example, smoker, no, and all that. It could not handle it. So before plotting correlation matrix or before studying multi-collinearity, this step of converting every numerical into every feature or every column into numerical variable, that is very important step. Now if you write correlation matrix is equal to df underscore encoded dot core and just display it, you can see a nice correlation matrix. How to read it is very clear. First, these diagonal points 1, 1, 1, 1, they are the correlations between a feature and itself. For example, this is between total bill and total bill, because horizontal and vertical if you go, and that is total bill and total bill. This is correlation between tip and tip. This is correlation between size and size. So obviously same two features are there, and therefore correlations are 1 for these all diagonal points. So they are not important, but whenever you take two different points, for example total bill and tip, this much is the correlation between them. Then total bill continuing horizontal from the first only, but here size, that is size of the group which has come for lunch or dinner. Total bill and gender female, negative correlation. So that means females tend to be a little bit cautious while spending, and usually if female customer is there, then total bill will be less. Total bill and smoker, no. So non-smokers are also appear to be cautious people, and the negative correlation is there, though it is very mild. Total bill on Friday is also negative. Total bill on Saturday is positive correlation. Total bill on Sunday is even stronger positive correlation, and total bill for time dinner is even positive correlation, right? Similarly, if I take the second row, then between tip and total bill, so it seems a very strong correlation that we had already seen in total bill and tip, right? So this is between tip and total bill. Then this is between tip and the size of the group. So again, strong positive. Tip and the gender of the customer. Okay. Tip and the non-smoker or smoking behavior. Then tip and the day Friday have negative correlation. Day Saturday have negative correlation. But on Sunday, people tend to give higher tip. So there is a positive relation between tip and the day Sunday. Okay. And time dinner, again, there is a positive correlation. So you can find it like this. Here we have discussed this whole thing which I have described. So I am straightaway going to that part. Now we first calculate correlation matrix. This is itself correlation matrix, and its syntax is very simple. Data frame dot core. Okay, but data frame must have all the features in numeric format, and if they are not in numeric format, then you use one hot encoding. Okay, so data frame dot core, and then you can write, you can find correlation matrix like this. So we first calculate correlation matrix and then plot a heat map. That we have not yet done, but heat map is just a graphical representation of this. So if some persons are not comfortable with reading numbers and they are more comfortable with a visual display of this, then for them we draw a heat map, which is a visual representation of correlation matrix. This visual representation quickly helps us to identify highly correlated feature. Okay, first let us do heat map. We will tackle later on. First let us do interpretation of correlation matrix. So it says that total bill and tip, there is a strong positive correlation 0.6757. I have pasted the same correlation matrix in a markdown here just for your convenience, so that as you read here, you can see the same thing here. So total bill and tip has strong positive correlation, indicating that higher bills tend to come with higher tips. Okay, this is expected as often tips are calculated as a percentage of total bill. Normally, there are certain customs that 10% of total bill should be given as a tip or something like that. So, as a result, higher bill will give higher tip. So, there is a positive correlation between total bill and tip. Total bill and size of group. So, that is this 0.5983. They also have significant positive relation that indicates that larger group tends to have higher bills, and therefore they also because that is clear again common sense. And remember, common sense always is not correct, but in this case it is correct that a larger group, more number of people, they will order more items, so therefore more bill. Tip and the size of group, again that also must be having positive correlation, because tip and the size highly positive correlation 0.48, but not as strong as this. You can say slightly moderate positive correlation. Again, it is expected because if more number of people come for lunch or dinner, then the total bill increases, and as total bill increases, tip also will increase because it is usually calculated as a percentage of total bill. But this is less strong because the correlation is now only 0.489. Okay. Then gender differences. So you can see that the variable sex underscore female shows negative correlation with total bill. So female tend to eat maybe less, and therefore the total bill is less, right? Then sex underscore female and the tip, they also have negative correlation. Sex underscore female and a tip minus 0.088. So negative correlation. So female tend to give smaller tip because their total bill is less. So tip as a percentage of bill will be less. And female tend to come in smaller group size also. So males seem to be more what you can say believing in brotherhood and large groups visit compared to females. Females come with few chosen friends. So smaller group. Okay. So that means female players might have slightly lower bill tips and the smaller group size. Okay. Then smoking. Now, we wanted to study this data set. This is a real life data set, and psychologists often use the data set to get correlation between behavior. It is called behavioral analytics. So, correlation between smoker no and the bill size is mildly positive. So, it seems that total bill and not bill size, sorry, but the group size. So, it seems that no smoker tend to come in larger group compared to smokers. Okay. So, that is one thing. And similarly, smoker no has negative correlation with day Friday. So let us see smoker no, that is this column, and go down, and day Friday is this row, that is this row. So minus 2.443. So that means that somehow the data says that non-smokers are less likely to eat out in the restaurant on Fridays. Okay, but on Sunday they have 0.18 correlation. So that means on Sundays non-smokers are likely to dine out, while on Sunday okay, then day of the week, the variables Saturday, Sunday, Friday have notable negative correlation with each other. Now that is obvious because same day cannot exist simultaneously, right? So day Friday, its correlation with day Saturday, that is minus 0.2163. Okay, because a day cannot be Friday and Saturday simultaneously. Then every day has negative correlation with the other day, and also it is seen that this okay, meal time. So dinner time shows positive correlation with day Saturday and day Sunday. So it seems that on Saturday and Sunday, people like to have dinner outside. So this is the correlation between day Saturday and the time dinner 0.46, and this is the correlation between day Sunday and the time dinner 0.41. So the strongest correlation is with Saturday for dinner because people are relaxed and next day is holiday. So that is why people tend to eat more likely. People are more likely to eat out on Saturday. Okay, Sunday also, but Sunday is slightly weaker compared to Saturday. So meal time has effect. Then time dinner has positive correlation with total bill and tip. Now total bill, if it is having time dinner and total bill, they have 0.18, this much correlation. So it is clear that if total bill would be more at the dinner time, then it is clear that tip will also be more because it is found as a percentage of total bill. Now finally you can draw this heat map, and heat map is drawn by SNS.heatmap. At that time you just have to pass the argument core matrix. That is the correlation matrix which you found by data frame name.core that you have stored in a new variable. That variable you are using here, and core matrix. Other arguments, annotate is equal to true and cmap is equal to coolworm. So among them, annotate is equal to true. That is important, but other two you can temporarily even forget because initially it is always easier to start with fewer arguments. So SNS.heatmap, first is your correlation matrix which you calculated by dataframe.core, and second is annotate is equal to true. And if you write it like this, just plot it like this, SNS.heatmap, then you will see this kind of heat map. So that means those other arguments, they were not compulsory arguments. They were just required to make the appearance slightly better. Okay. For example, how appearance will be slightly better if I include them. One is that the color code of these all cells, here I find this color perfectly alright, but some people may prefer lighter colors. So for that, he may choose a color palette. So that would be the third argument here, right? And the fourth, one more thing is, here there are 3 digits after the decimal point. Here there are 4 digits after the decimal point. So some people may say that I just want 2 digits after the decimal point and round off the other things. Okay, so that can be achieved by those other arguments. Annotate is equal to true is absolutely necessary, because that gives a much better look to my heat map, because the correlation between two variables is also included inside each square. So this is 0.68 means what? Total bill, it has 0.68 positive correlation with tip. Okay, and that is same thing is seen here. Total bill has 0.6757, that is 0.68 positive correlation with the tip, right? Similarly, so I want not only the color, because color will give me some idea that closer to the lighter side there is 1, exactly at the middle darkest one, that is 0, and closer to the other side black darkest on the other side, that will be -1 correlation. So I can decide positive or negative correlation just by looking at the color only, but that would not be very clear. So what I'm saying is, if I just write annotate is equal to false, okay, and then I just plot, this kind of plot is okay. Now there I have to guess the correlation from the color combination which is given on the right side vertical thin color scale. But instead of that, annotate is equal to true is always better. Okay. So annotate is equal to true. And what about those other parameters? So those other parameters were like this. Scene map is equal to coulomb. So instead of this dark one, I will want coulomb. And instead of the four digits after the decimal, I just want 0.2f format. So that means format is equal to 0.2f means keep only 2 digits after the decimal point. If you plot it, it is a much better looking diagram. But these are all extra frills. Okay. The thing you have to remember first, basic thing is sns.heatmap and core matrix. Okay. Because I think, let me try. Perhaps I think even annotate is equal to true is also perhaps a default option. No, it is not default option. So then, okay, 2 arguments you will have to remember this many. This is required only if you are interested in lighter and more clearer heat map. This heat map is showing the same thing as this correlation matrix, but in a visual manner. Okay. Now, this is what discussion we have done. What thing you should pay attention on the heat map always is one on the color spectrum. So you should pay attention on this right side spectrum. Now, as I chose this coulomb color palette, so now my white stands for 0 correlation, and as I go towards darker and darker color on the red side, then my positive correlation increases. So from yellow to orange to dark red, then positive correlation increases. For example, this is the yellowish, okay, then this is orangish, and this is dark red, and positive correlation increases. And from white, if I go downwards towards light blue, then slightly dark blue and extremely dark blue, then negative correlation increases. So light blue, that is -0.13, that is this kind, okay, this -0.14, then slightly dark, that is -0.17, still dark, -0.24, still very dark, -0.50, here also -0.50. So one, you should pay attention on color spectrum. Second, you should pay attention on the magnitude of correlation, and for that only this annotate is equal to true, annotate equals true. That is a very important requirement. Then diagonal line, that I showed that this diagonal line shown by 1 correlation, that is correlation of each feature with itself. So that is why that correlation is only 1. And the heat map is symmetric above the diagonal line, that is on upper side, and below the diagonal line. So much so that in fact many times only this much heat map is plotted, lower part. That is a triangle, a right angle triangle, this much, where my cursor is moving. Because that contains all the information, and the upper part is just a mirror image of this. You can see here 0.18, here 0.18, here 0.12, here 0.12, here 0.10, here 0.10, here 0.05, here 0.05, like that. So ultimately, there is only need of only lower right angle triangle. Some may say only upper right angle triangle. That will give complete information. So the line is symmetric, the diagram is symmetric with respect to the diagonal line. And the patterns and clusters, they are important because here there are not much pattern. Here there is some pattern that some negative correlation is there. But their example was here. You can see a clear pattern, cluster, that average air temperature, average minimum temperature, average maximum temperature, that whole cluster of features seems to be just representing only one feature, because they have 99 or 98% correlation. That means these are not 3 features, but just one feature. You can write temperature. Okay. So, and you can add 3 values and divide by 3, that will give the same result as keeping 3 features separately. Okay, and that's it about correlation matrix. And the heat map, it became slightly longer because we explained that one hot encoding also. But remember, you had learned two important things. What is one hot encoding? What is the significance of drop first is equal to true and drop first is equal to false in one hot encoding? Then you also learn how to plot correlation matrix df.core and how to plot the heat map. Then that is store the correlation matrix df.core in a variable and take that variable core matrix, take annotate is equal to true. Other parameters are just for better appearance. So if you want, you can take them. Okay. So we see in the next lecture this variance inflation factor, and with that, because that is just a very small discussion, so with that we will also take this ANOVA in the next lecture. Okay. So thank you and see you in the next lecture.